In video 4 of the third lesson in section 1, we will take a closer look at the mean, median, and mode for a data set and discuss which measure of central tendency should be used in various situations. All three values are considered averages. But are there instances when mean should be used to represent the data instead of median or mode? Or are there cases where median should be used rather than mean or mode? And when is mode most useful? Let's have a look. For a given data set, what measure of central tendency do we choose? How do we know which one best represents the data set? Keep in mind that the idea of a measure of central tendency is that we are choosing a value to be representative of a set. Deciding which one to use will often depend on the situation. There are some guidelines that we can follow. Let's first consider mean. In video 3 of this lesson, we talked about continuous and discrete data. Mean is useful when the data is continuous. Partial time, partial heights, partial distances all make sense. Be careful using mean if you have extreme values, and we will talk more about this in the next couple of lessons. Extreme values will be data values that are noticeably different from the rest. Mean is useful when none of the data values are significantly different from each other. And mean is often preferred because it uses all data values in its calculation. Some guidelines for median. Median, too, is useful with continuous data, but it is not influenced by extreme values. Median is often used with data that is skewed. We could get into an intense discussion about data being skewed, but we will keep it fairly simple here. The idea of the data being skewed is that in this graph, for instance, there would be more smaller data values compared to middle or larger values. If our graph was skewed to the right, there would be more larger data values compared to smaller or those found in the middle. And a few guidelines for mode. Mode is useful with discrete data. If you think about a bar graph, it would be the tallest bar, the most popular option when we talk categorical data. For instance, what is your favorite food? What is the preferred brand name for your hockey stick? What is your favorite literature genre? The results from these questions would be categorical data. Mode is very useful when we talk shoe size, clothing size, small, medium, large, and so on. Be careful using mode if the most common data value is far away from the remaining data in the set. And recall, if there's no repetition of a data value, then no mode exists. Let's consider an example. The heights in centimeters of 8 athletes on the CDL high track team were measured. 152, 154, 168, 172, 169 and 5/10, 16, 159, and 160. Our task will be to calculate the mean, median, and mode for the data set. Which measure of central tendency would you use to represent the data? I will tell you up front here that when we do these calculations, we will include all 8 recorded measurements. And the reason why I'm stressing that is if you look at the 16 centimeter recorded measurement, you may certainly question that. If you think about your typical 15 centimeter ruler, we're saying that one of these athletes is just slightly taller than a 15 centimeter ruler. That is indeed questionable. However, as I said, for now, we are going to include all of the recorded measurements in our calculations. So let's have a look at mean. Our algorithm for mean, we add all of the data values and then divide by the number of data values present. We are adding 152, 154, 168, 172, 169 and 5/10, 16, 159 plus 160. Divided by, there were 8 athletes, we divide by 8. If we add these values, all of the heights, we will get 1,150 and 5/10. Divided by 8, that will be approximately 143.8 centimeters. That's the calculation for my mean. Let's have a look at our median. For the median, our first step is to organize our data values from least to greatest. 16, 152, 154, 159, 160, 168, 169 and 5/10, and a 172. That gives me 8 pieces of data for the 8 athletes. 8, of course, is an even number, so we will have 2 middle pieces of data. I can group the first 3, group the last 3. My 2 middle pieces are 159 and 160. And though I suspect you can certainly figure out the middle of 159 and 160 quite easily, there is the process of adding those 2 values, dividing by 2, which is finding the mean of those 2 values, and we will get 159 and 5/10. Midway between 159 and 160, 159 and 5/10 centimeters. That's our median. Our mode for this data, when we look at our data values, there is no data value that repeats itself. Therefore, no mode. In choosing then a measure of central tendency to represent the data, we have a choice between 143.8 centimeters and 159.5 centimeters. If we follow our guidelines, and if we are including all data values in the calculation of our measures of central tendency, the best measure of central tendency to use here to represent the data is definitely our median, 159.5 centimeters. The guidelines from the chart, remember, if we have a data value that is significantly different, it's extreme compared to the other data values, the mean is probably not the best choice. We certainly see that here. If our mean calculation is 143.8 centimeters, and if we look at our data, that value is very much less than the majority of data values in the list. The 16 centimeters, whether it makes sense or not, if it is included in our data set, if it is included in our calculation, it will have a significant impact on the mean value. As a result, the best measure of central tendency to use here would be the median. Please proceed now to the next video in this lesson, where we will examine a couple of more examples relating to this topic.